Okay, so we have two rules that we need to look at today. One is if you have things being multiplied, and it doesn't matter how many of them, being raised to an exponent. Here's what's going to happen. If you were to write this out, it would be saying that I have x, y, z twice, right? And so because it's all multiplication, I can rearrange it. And so I can write the x's together, the y's together, the z's together. And when I do that, I can write x squared, y squared, z squared. So if you look at this, I could have shorthanded this and said, well, because it's all multiplying, and that's super important, because it's all multiplying, I can go ahead and distribute the squared to all of them. And that works no matter what's going on or what your exponent is. As long as it's multiplying, you can do that. One of the things I want to caution you with is if it is, if there is a number in front, that also gets the exponent. So here's what's going on. You have 2xy times 2xy times 2xy, right? That's all being multiplied, so I can rearrange it. I've got 3 2's, I've got 3 x's, and I've got 3 y's. And so I could have gone 2 cubed, x cubed, y cubed, and then you should actually figure out what 2 cubed is. Okay, so that's the first rule. The second rule is if we have two things being divided, so the first rule is multiplied, what if it's divided? Well, let's see if the same thing happens. So I have x over y times x over y. And when you multiply fractions, you can go ahead and just multiply across the top. So you get x times x and y times y, which would be x squared over y squared. So then that means when things are being divided, we can go ahead and distribute the squared to both of them. And that happens if we had, let's say 2x over y. If I had that to the third power, I need to apply that just like I did with multiplying. I need to apply it to everything on the top and the bottom. So then we get 2 cubed x cubed over y cubed. And then I would have to simplify that 2 cubed is 8.